This is the entire radio spectrum from DC to 100 megahertz. The computer is a Supermicro X9 DAI with 2 processors in it, each one having 4 cores. Hyperthreading is disabled because it destroys performance. We have FM band here. I'm tuned to one of the local FM stations. You can see on the green line where Linrad has been clicked. We have the HF from DC, very little on long wave and medium wave, and then we have around 10 to 15 megahertz, a lot of signals, and it ends at about 30 megahertz. We can see ionosondes. Here is one. Here are 2 others. They go all the way up to 28 megahertz or something like that, and they repeat regularly. As you can see, we have it here and then it comes back here. There are many local, I don't know what it is, but between 65 and 78 megahertz or something, and also a bit above 80. Very little between 50 and 60 megahertz, and something here at 40, 38 or so. There is computer interference, this hump here, here one, and here is something also. This antenna is not good at all, it's just a coaxial cable with about 5 meters of wire at the end. There is no choke on it and no protection against interference from the computers leaking out to the antenna.
Nyheter får vi nu här i P1.
The load on the system, you can see here, system monitor, and you can see the load is high but not 100% anywhere, and sometimes there is a little bit free capacity which is now used by this. I make an archive with all the parameter files in this directory where Linrad is now running. And then I save it in another computer from where I can download it into Windows and all the other operating systems.
Oftast är det de små partierna som saknar representation i beslutande organ som råkar ut för problem.
And then I log in here.
Feministiskt initiativ, FI, har erfarenheter av detta i flera val nu. I årets val redan under förhandsvalet, och idag på valdagen har det kommit in fler exempel på det som Fanny Gustafsson inledningsvis berättade om. Felaktig information.
So now it's stored permanently somewhere else.
Nu har vi flera exempel på att de personerna som har frågat har fått informationen om att...
And you can see Linrad runs beautifully, there are no glitches, no error messages. I can zoom into the FM band, I click here and feed the lower frequency, 88 megahertz, up to 100 megahertz. Enter and then click on apply. And here we have the FM band and I can listen to the different stations. That was the same. So this is very nice, I think. It's very interesting that on other operating systems it is usually not so nice as this. I can go out, X, and then go for AM, that's F. Here is the HF and low frequency part. And I have tuned to 7.2 megahertz. I can use the wheel mouse to listen. It's not so easy to click on a station because stations are too close spaced when all the nearly 30 megahertz is on this screen, which is only maybe 1000 pixels from here to here, 1200 perhaps. You can see the ionosons coming here, and we have this ionoson which comes back up here. I don't know how to get something useful out from that, but probably it could be done. I can zoom into a band, like for example from 7 megahertz to let's say 7.5 and apply. The resolution here is not very good, and this is something that can probably be improved, but I'm not sure that this computer would have the processing power to do that. Clicking into the spectrum is not a very good idea. Here we can see where the strong stations are. Or maybe here. So I don't know what that might be. Well, this is for the DX listeners and others to investigate. This video is about computer problems with running this kind of very demanding hardware. I will restore the original parameters that I saved before here, and then run Linrad again. I have now connected a signal generator. Go to FM mode, E, and you can see the signal generator is here. And I tune it upwards. No, that's this direction. This is to show the aliasing. The hardware is a PCIe 9842, and there is a preamplifier in front of it, but there is no filter. So it's only the anti-aliasing filter of the card itself. And you can see here the aliasing comes back. So this means that the bandwidth is far more than 100 megahertz. Frequency is now 120, of course. We are 20 megahertz from here to here. And I go a little bit faster. here. This is 144 megahertz here. So with a suitable bandpass filter I could listen on 2 meters directly with this card. And continue further up. And I'm approaching 200 megahertz, which we have here. And I have to switch on the signal generator. This is 420 megahertz here, and I go downwards. Sensitivity is not so impressive. I click on it. It shows minus 60 on the S meter. Here is the minimum. And here we are at 44 on the S meter. So this shows the need for anti-aliasing filters. I've now connected a very good crystal oscillator. You can see the signal here. And glitches now become far more visible. You can see some small glitches here that we didn't notice before. I can tune this on the side like that. And we should be able to see glitches on the S meter now, in case there are any more. The signal level is very high. I press A to read the amplitudes. You can see here. It's 1 dB below saturation. And the computing cost of computing the amplitudes overloads. You can see we have a lot of glitches now. So I disable this again by pressing A again. And the errors disappear, or mostly disappear. Maybe it's better to get rid of that. So I leave this running for a while and clear the things first, X, and then back. And like this. So I will leave it like this and come back after a while. There is now about 10 minutes. On the waterfall we have 2 glitches. You can see it here in the baseband also. So it is nearly stable. These are not very serious glitches. They come at infrequent intervals. I will now show something really intriguing. Oh, here was one more. I will reboot this computer. And I do it easiest, Control Alt F2, Control Alt Delete. and go for the same operating system. That's Debian SID, the 64-bit version. And then I press E to go back to exactly where we were before the reboot, like this. And you can see it looks awful. A lot of errors. The computer doesn't look okay at all. You can look at the system monitor here. And it shows the load is not so high as it was before, but there are occasional events of overload. So this is no good anymore. But I can escape and then start. You see the underrun errors because of loss of data. I start Linrad again and E. And it's still bad. But it's not quite as bad. Interesting, isn't it? So escape and restart. And I think it has to run for a little while. The thing is, this operating system is learning that Linrad is a difficult task to run, and something is adapting. I do not know what it could be. So escape and restart and E. And move it outside. Now it starts to look okay again. I had to run it 1, 2, 3, 4 times to get the system become aware of what is required to make this piece of software run properly. If I now look at the system monitor here, you can see the load is much higher. And this glitch was perhaps when I started the system monitor. Maybe I should exit and run it once more. E. And click. So now it's okay again. This is only working on a modern Linux. If I go for an earlier version, it will be different. So I will demonstrate that now. I have just demonstrated Debian SID 64-bit with the kernel 3.14. I will now go for Debian Wheezy. That is the current Debian stable. So go here. First I make sure that this Debian stable is the very latest by today. Update. And upgrade. Yes. Next, verify that I really booted into the latest kernel. That is ls boot, and the latest one is 3.2.0 -4, and you name and that's the one we are running. Then go to where I have the repo downloaded and make sure I have the latest version, the one I was using under SID. svn up. And it couldn't find my keyring, but that doesn't matter, I don't have one. Now everything is updated. Insert the module. And go into the Linrad directory and copy everything that was from the repo. Like that. And compile. Sorry, configure. ./configure and make. Now go to that other computer and get the parameters that we have been using. FTP and quit. And unpack this tbz file. So now all the parameters are in place. I make the screen whiter, that's F11, like that, and start Linrad. And go to the FM mode, E. And here we are. There are many glitches, but that was the case also on the Debian SID the first time. You will see all the error messages, and there is some speed error, and it's awful. So escape and restart, and E. It's not very good yet. So I'm now allowing Debian Wheezy to get trained. What's that? F11. And then It seems to be better to make the screen bigger this way. Like that. So now it has been running for a while. Let's escape, Control C, and then X Linrad, and E. This is the third time, and it's still horrible. Can leave it for a little while, and then escape and start Linrad again, and E. Now it's better. So also Debian Wheezy has a learning curve. But you see there are several glitches here, and you can see them on the S meter also. So escape, and it was 1, 2, 3, 4. Now I will start for the 5th time. And there was some problem. We have to wait for a while. I switch off the camera and switch it on again after 10 minutes. It's quite obvious that Debian Wheezy is not as clever as Debian SID in learning how to use the CPU resources best for Linrad. The frequent glitches, and you can see them here as well. And it doesn't matter how many times I start and stop Linrad, it doesn't become better than this. This is Windows 7 Professional. Here you can see the information about the system. I hope it is readable. It is an E5 2637 version 2 at 3.5 gigahertz. And there are 2 of them. A lot of memory. So close that. I go to the computer where I stored parameters before, connect, and there is a directory Linrad here, and remove everything from it, delete all, and then I have the latest version from the repo here, compiled under Linux, and also here unpacked this BSZ-par that contains all the parameters that I've been using for these tests. Copy them, and then start Linrad. And here we are, and E for FM mode. And I click on the signal. And this looks fine. Very high CPU load on one thread. I can press T to see which one. It's the narrow band processing, that's the FM detector. It's very near the limit, but it doesn't cause any problem, as you can hear. I have now connected the antenna and clicked on a FM station. I will now change the span. So we see a smaller part of the spectrum.
Han kommer att avgå och Stefan Löfven uppgiften och bilder in något scenario där den här frågan
like
går
this.
tillbaka till alliansen utan ett mellanliggande nyval.
Ja, det beror ju på. Alltså, det här är ju nackdelen med att de rödgröna inte har presenterat ett gemensamt alternativ innan. När vi tittar på de olika krav man har haft i sina respektive valmöten så har vi ju 90% av deras
leave this and parameters. And I will change the load on the baseband, that the FM detector and so, by going here with a bigger value, means half the sampling rate in the baseband.
Kan vi givetvis komma på fråga om att återigen se vad finns det alternativ till att bilda regering.
Now there are problems.
Förutsättningarna ut för det då är ju en ledare för alliansen som är på väg att sluta.
This does not happen under Linux. It's a problem under Windows 7 only.
Till exempel skattehöjningar på mellan 30 till 90
And if you look at the threads, you can see that this one has a low load and this one as well. The problem is likely to be related to the control of the speed of the processors, because the error we see here, that belongs to the PCI bus. Data is missing for some reason.
Rösta ner den när man ser att vi skulle kunna gå fram på samma linje i röstningen där. Hur ser ni på att göra?
This is Windows 7 Home Premium. It sounds terrible. It is hacked and maybe 50% of the sound is absent. Opening the task manager shows the reason. We have only 4 CPU cores, which means that we don't have enough CPU resources at all for the parameters Linrad has been using in the previous examples. So forget about Home Premium. This is the 64-bit version of Windows XP, as you can see here. I have installed the test version I used previously in this video with the same parameters. And I start Linrad. The antenna is still connected, so I expect to catch some music on the FM band. Or maybe somebody is speaking, I don't know. Okay. I prefer to listen to somebody talking, because if there is music, Google is going to make problems for me. Copyrighted music has to be cut out from the videos I make. So this seems to work without glitches here. There was a problem in the sound because of overload somewhere far down in the signal path. You can hear this. I solved that by making this bandwidth reduction 1 unit bigger. That's something I want to do anyway, because I'm going to look for this problem that was visible in Windows 7. So I click here. And take something else. I have to jump between the stations. Okay. Well. Now something has locked up. These are... Now I have problems. And that's why it is locking up also. We know that shit ain't come on now, mate. How close we get sometimes. It's like we never met. And you can see here there is a problem. It's of the same nature as I saw in Windows 7. Something is going wrong. And I'm pretty sure it is the PCI bus or the driver for the PCIe 9842. Probably one of the processors is running slowly, and when it is used to handle something important, there isn't time for it. And this happens when the load is low on this thread as well as on this thread, and high on these threads, then we have this problem. And I don't see the same problem under Linux. Now I'm back with Debian SID. I have set those parameters that are problematic under Windows, and they are not fully okay here either. You can see there is error messages. Samples are lost at the input, it seems. It's not enough to make a noticeable interference to the output. It sounds perfectly okay, this is what the guy is saying. I will connect the crystal oscillator and look at the glitches. Now I'm looking at 20 megahertz from DC to 20, and you can see that there are a lot of glitches on the crystal oscillator. These things are not noticeable, or not much noticeable, in the FM mode, but we can see it here. And probably the reason is the same as under Windows, but I cannot claim that I understand it really. This is Linrad. Linrad with the frame buffer and without X11. And this is with the parameters that didn't work perfectly well under X11. And you can see here the load is small, the load is small, the load is high. and there are no problems. And if we look up here, there are no traces of any glitches anywhere. The X11 server is a substantial load, and it's better to not have it. You can see here there is no loss of data anymore. I will show the parameters that have been used in this video. That was FM mode, and I go to the parameter screen, X and P. The bandwidth is set to 6 kHz. That gives an FFT size of 32,768, and that is the maximum size for this FFT implementation that is using single instruction multiple data, some kind of multimedia instruction. That is the FFT, first forward FFT version number 3. It computes 4 FFTs in the algorithm in parallel. There are 5 threads doing that in parallel, which means that there are in total 20 parallel computations of the bulk of the FFT. The window is number 9. That's an expensive window, but it gives the best alias suppression. And storage time is 0. If I put 1 second here, there is not enough memory. Because this is the 32-bit version of Linrad running under a 64-bit operating system. It's only for the 32-bit architecture that I have the assembly routine for the single instruction multiple data at this time. The first mixer bandwidth reduction is 7. 8 is 256, so 7 is 128 times. That is, the sampling speed is 200 megahertz, but in complex format it would be 100 megahertz. Divided by 128 means something like 800 kilohertz or so. The third FFT window is 2. That's not a particularly good window, but we don't need very sharp, very steep corners on the baseband filter for anything I have been doing here. And we are back at this.